For each identity, we're going to want to say the non-permissible values and prove them. Now, for non-permissible values, in mathematics we've learned some things are not allowed. Not allowed to take square roots of negatives, not allowed to divide by 0. In this situation, we're mainly going to worry about dividing by 0. And we have to check everywhere where we're dividing in the equation. So what I'm going to do is I'm actually going to prove it first. Starting with A, we have cotangent of theta over cosecant of theta equals cos of theta. Draw my line. In this situation, I look at both sides. The right-hand side is in cos already. So I'm going to just change everything to sine and cos and see what happens. So cotangent of theta is cos theta over sine theta. Cosecant of theta is 1 over sine theta. And from there, I'm dividing a fraction by a fraction. Cos of theta over sine of theta, multiply by the reciprocal. These factors are the same. And we've proven it. Now to find out where it is undefined, because that's what the question is asking, we have to say to ourselves that we can never divide by 0. So I'm going to pull out my highlighter and just check places where I'm dividing. Right-hand side is cos theta, never dividing by 0. On the left-hand side, can you see that I'm dividing by sine here? I'm dividing by sine here. I'm dividing by sine here. I'm dividing by cosecant there. Those are all the places that I'm dividing by 0. I'm sorry, not dividing by 0. Those are all the places I'm dividing. So what does that mean for my non-permissible values? I have to look and say sine of theta can't equal 0. And cosecant of theta can't equal 0. And I check, and those are the only things I'm dividing by. When is sine of theta equal to 0? That's our y coordinate. Zero, pi, and 2 pi. But does it ask just for one time around the circle? Does it ask for all the non-permissible values? It was asking for all of them, so we're going to have to do the general solution here. How would I write this as a general solution? Well, I can put them together. I could have done 0 plus 2k pi, pi plus 2k pi, 2 pi plus 2k pi. Can you see that I can combine those all together by just doing k pi? And if you were solving this, cosecant theta, not x, almost did an E3 error, changing the variable. Okay. Cosecant of theta, when is it equal to 0? Well, that's like solving 1 over sine of theta equals 0. When is a fraction equal to 0? Only when the numerator is equal to 0. Does that make sense? If you have a fraction equal to 0, it only happens when your numerator is equal to 0. What's our numerator? 1. Is 1 ever equal to 0? No. So I could look at this right now and say there's no solution to that. I could have multiplied both sides by sine of theta. And if I multiply both sides of sine of theta, I get a very interesting thing. 1 is equal to 0. Okay? That is not true. That also tells me that there is no solution because that's not true. If you think that's true, give me $1, I'll give you $0 back. And we'll just keep doing that until you are convinced, okay, it's not true. So our only non-permissible values are multiples of pi. Okay. We've got another proof in part B. Again, I'm going to let you do that one on your own on scrap paper. And your questions for practice are 4, 8II, 9II, and 11.